Hi. Hi, Taylor. So I want to talk to you about the async stuff today, and specifically around the future of what we should do. That's a really awkward sentence. Specifically around figuring out what are the best next steps for us to take and kind of pick your brain on this. And I'm probably going to make a little place to take some notes. Let me do that. And I'll share it just for fun. Okay, but so I had this little list of like stuff we might do in the near future. But before we talk about that, I'd like to hear a little bit more. I mean, I know who you are, but maybe someone who's watching doesn't. About what you were doing around async, what the project you were working on was, and how it was special and cool.
Yeah, so I guess I'll give a background on myself in a few different ways. So I am first and foremost for like Rust things. I'm a compiler team member and a language design team member, and have been for a couple of years now. I maintain the Futures RS library, which is one of the foundational crates in Rust's async ecosystem, and I helped with the design and implementation of Rust async await and future abstraction. And I also worked on the Fuchsia team at Google, which uses asynchronous Rust really heavily for developing low-level OS microservices for performing common tasks. Fuchsia in particular is a microservice, it's a microkernel, which means that there are a lot of things that would typically be placed in the kernel, which appear instead in user space level services. So you can think about it as sort of like software as a service, the operating system. And so a lot of the typical like distributed system problems and software as a service problems that come up around asynchronous development also appear in Fuchsia pretty heavily.
So my impression, I actually don't know very much about this. That, for example, I did not know that this was a microkernel architecture, but my impression is from the kind of concerns you would bring up that Fuchsia tended to like lean pretty heavily on a certain sort of very lightweight profile, like single-threaded executors, for example, and kind of peak performance around, I don't know. I had the impression there were a lot of really small things moving a lot of messages pretty fast, and that overall latency and throughput really mattered to you. Seems like I was probably correct, but is that right?
So it's particularly latency is the sort of go-to thing for us because when you were responding to user action, right, you need to have a really low end-to-end latency. And when things are hopping through several different services rather than just maybe one process in the kernel, you have to work to minimize like all the various like wake up times of each of those things and each of those separate processes. We don't throughput isn't as much of a concern for a lot of these processes. I don't know which ones are great examples to give, since the overall sort of design and things of the operating system aren't public. I can't talk too much about a lot of the specifics there. All the code's public though, so I can talk about like structure of things.
Yeah, I guess I was really just not thinking too deeply when I said latency and throughput, using that as a shorthand for perf, but latency makes sense.
Right. Yeah. Yeah, and in particular, what that means is that there are a lot of sort of low QPS services that exist that need to be ready to respond from a sleeping state very quickly and respond to a request very quickly.
And well, that's interesting. I'll put that down. But I don't know how it matters, but it's interesting. The next question I had is, you all had kind of your own sort of runtime that you were using, right? From
Yeah, so
scratch
we have
implemented essentially? Or?
right. So we have our own asynchronous executor, which means that we don't use the Mio and Tokyo stack, and we don't today use async std, which didn't exist when we started the project. We have a variety of so typically tools like Tokyo and other asynchronous systems are built on top of a thing called ePOL, which gives you sort of event-based access to different I/O primitives, in particular like sockets in Unix land. On Fuchsia, we have a lot of things that are go through a sort of similar tool that gives us wake-ups and events, but they aren't necessarily things that look like Unix sockets. So, for example, Fuchsia has a type of handle called a channel that can be used to send messages that contain both a byte stream and a list of capabilities of handles that can be either other channels or a socket or permissions to access some particular region of virtual memory. There's a much longer list, but the point is that there's a much wider range of sorts of evented objects that we need to support access to in an asynchronous fashion than something like Tokyo is supports today on Unix.
How much, one of the things I'm wondering about is how much we should be working on sort of extending the base capabilities of what we can offer versus specifically focusing around interoperability between runtimes. And I think, I'm not sure how many things do a little of both, probably a lot of things, but I think like a lot of the, if you look over the list of ideas, they kind of fall somewhat into one of those two camps. How much do you think it would benefit, say, Fuchsia if, like how important is interoperability to Fuchsia? Do you see what I'm trying to say? It seems like it would be useful to you if you can use more of the Rust ecosystem, I guess.
Interoperability of binaries is not super important because we expect that we have to modify things to have different behavior just because of how Fuchsia is structured. It doesn't operate like a traditional Unixy OS, and so applications that are built with a traditional Unixy OS in mind aren't going to work very well. What does matter a lot is that we're able to reuse parts of Rust's library ecosystem. So, for example, we currently make use of libraries like Hyper, and as well as other libraries like the Quick Stack from Cloudflare and things like that that are all various asynchronous bits and bobs, right? And it's really important for us to have like an HTTP stack, right, that's asynchronous and that we're able to use on our platform. Today, oh, sorry, go ahead.
I was just going to ask how that worked. I was under the impression, perhaps mistaken, that Hyper was pretty tightly tied to Tokyo.
It actually is not. So Hyper and a lot of the things that it uses, like H2, are written in such a way that you can pass in arbitrary things that implement various traits. There's like a TCP connector trait that has to yield a type that implements async read and async write traits from Future 0.1. This is talking about Hyper pre the new like async await supporting release.
Okay, so it's only that it's using these traits that are somewhat generic. Maybe some of those traits are defined by Tokyo. I'm not sure. I guess I'm not sure how the newest version is working. I know Tokyo's like actively looking at revamping the async read and write, for example.
So there's actually an open PR right now that Sean has that maybe, I don't know, if you're planning on doing a version of this talk with him, that might be an interesting thing to discuss, or we can do it now, but I think I have a little bit less context than he and Carl do.
Right. I was hoping to talk to him and Carl.
Yeah. But so that they have their own version of the async read and write traits that they're introducing in Tokyo new. I don't know what the numerals
Right.
that have been cited on yet are, but yeah.
Right. Yeah, I agree. I should. But let's cut a little bit over to the other section so we have some time. Rather than, I don't want to dig into that PR in particular. But it is. But so okay. So, but I guess to summarize this, that was kind of what I was getting at, was stuff like hyper and quick. Like, what are the kind of big components that you would really like to be able to reuse?
Yeah.
What would you
So
need
a
to
key
reuse
thing
them?
there. Yeah, so a key thing there is that libraries are designing themselves around being used on different executors, and there are different libraries that have taken sort of different approaches to this, right? In other parts of the ecosystem, for example, in Rust CUI ecosystem, there's a handful of libraries that support like using particular like cargo features to enable support for a particular backend for the library. But that means that you have to upstream support for that backend into that library, and you have to add it as a dependency. For a lot of reasons, it's better for things like Fuchsia if we're able to develop our executor in-house and have libraries that we can pass objects that implement appropriate traits into.
Right.
And so that's something we've tried to encourage throughout the ecosystem. There are a lot of libraries that do a really good job of this. There are a lot of libraries that do an okay job of this. There are some libraries that don't do this at all and depend directly on types from Tokyo and async std, and we've done our best to try and communicate with those library authors and try and work to get those parts of their libraries moved under feature gates so that we can not enable them on our platform.
I guess it's also a question of which traits are available, right? Like, in other words, it's better to take in a trait. Like, if you can just take in any feature as your base thing and work with that, that would be the most interoperable because it's in standard. If you can work with async read and async write from, that's pretty generic, except that there's a lot of async read and async writes out there right now.
Yeah. So coming up with, there are a few async read and async writes out there at the moment. Trying to get ones that can be freely or close to freely interoperable is great. There's a mixed bag of how often that's able to happen. But
Right.
yeah, traits that accept futures or have some sort of trait that you can implement for your own custom converter type are great.
Yeah, I guess that's also an option if the crate exports its own trait. But,
right. So that's how Hyper works, for example, is like it exports a TCP connector or TCP acceptor trait that you can implement.
Right, that makes sense. So cutting over to this, I mean, that kind of leads in, I think.
Yeah.
What if you were going to take a couple next steps, and since I don't know how involved you're going to be in these things, you can speak separately or or in other words, you can separate yourself from the effort. But what do you think would be the best bang for our buck, so to speak, for our standardization or effort in terms of improving the state of async, and why?
I think the biggest things are going to be getting core shared std versions of the basic traits that everything sort of needs to use.
And what are those in your mind?
So stream is the sort of biggest one that has some core design issues that we can kind of gloss over or we can talk more deeply about. But that also includes async read and async write, and some of the ones that have gotten less attention, like the UDP and TCP interop traits, which would be needed for anything that's trying to be abstract over Tokyo. And I know that there are a handful of different libraries that have all defined their own like.
Do we have any of those in the futures crate?
TCP stream connection. I'm sorry?
Sorry, I didn't mean to cut you off, but do we have UDP and TCP interop traits in the futures crate?
There aren't any at the moment, but there have been some discussions about adding them.
Okay. So these primarily exist sort of in the ecosystem at the moment.
Yes.
Not in any semi-centralized place. Okay. I'd like to know what the stream design issues are actually.
Yeah. So one of the core big ones is that the version of Stream that I and a lot of other people want is, you could call it streaming stream if people are familiar with the streaming iterator design. But the TLDR of it is that it requires generic associated types, because what you'd like is to be able to yield items from the stream that reference some buffer that exists inside the stream itself.
Oh, I forget what is the stream method name called? Poll next or something? I don't know, but it's just poll. So I'm assuming the current one kind of looks like this, probably option, I guess, or something. And it's probably a poll, actually, of course.
Well, so it's both.
Right.
It's a poll of an option, and then it's, you know, pin and mute self, and
yeah. Okay.
but you don't have to. We don't have to be too precise about this at the moment.
Let's pretend pin never. No. let's just gloss over pin. Not that there's anything wrong with pin. It's beautiful. It's a work of art. But it's orthogonal to the discussion at hand. And so you're saying you would sort of prefer like I don't know what the preferred name would be for this thing, but something like this.
Yeah. Although, as we discussed in that conversation with Aaron, it's actually item where, you know, this where self outlives tick this, right?
Yeah, I know. I was hoping you wouldn't bring that up. Okay.
I would bring it up because I think it's important to remember that the common GATS thing that you want is more awkward to spell than you might like.
That we have not actually solved this huge ergonomics issue. And I have no idea how. Yes. So I am not going to explain why this annoying thing is necessary, though maybe I have a blog post somewhere. But suffice to say that for now, we might need something like that in order for everything to type check that you want. But the important point here, okay, I get it. So you'd like a streaming stream.
Yeah.
And okay. Have we thought about like forward compatibility story? Similar, I don't know what I have.
You mean in terms of whether we could define a stream trait like the above that implements the below within a blanket impl or something like that?
Right. Has anyone? Yeah, exactly. But like if we started with this stream that's analogous to iterators, and then
we've mapped that out a few times in the Futures Crate to talk about what it would look like, you know, when we introduce a streaming stream, what direction the impulse would go, and there's sort of a series of discussions that have happened there. But I think the most important question here is like, how do we get this understood so that people can rely on it once and for all, and that's the truly like 1.0 thing.
Well, the point would be, if we wanted to move forward with stream in the short term,
in standard,
would we have a path by which we have like a streaming stream and a streaming iterator, probably with a different name, that is somehow compatible? I don't know. I'm thinking about this and realizing there's a problem here because, of course, you can't implement this. Let's give these different names. You can't implement, I'll call this detached stream because,
yeah.
And I'm going to call this attached, even though that's not the name you used. Because the point being that this gives, when you call poll with this version, you get back a value that's independent of this reference to self, and you can just make it live as long as you like. Right. Whereas here it's like attached. It only lives as long as the borrow lives. So I guess there is no way to implement. I mean, if we added an attached stream later, you would implement anything that implements detached stream would automatically implement attached. Right.
So if you can write a bound that allows you to express that all of that essentially the item type is non-variant against tick this, right? You can implement detached stream for those, right?
Right.
And you can you can always implement attached stream for a detached stream, right?
So if we added if we added first detached and then attached, all the things, well, the problem would be all the existing impls of detached would be just fine because you could have a bridge that goes from detached to attached. I'm going to call this borrowing stream or something. I don't like this name attached. It's too confusing. So there's basically two directions, right? The impulse of detached stream would be just fine, but anything which was written like, there would be some set of functions that take a detached stream, but actually would be perfectly fine with the borrowing stream, right?
Yes.
They don't actually require that the value be separated, and so
yes.
those ones are now too strong. Any such function is now too selective, kind of, and could be weakened.
Right. So anything that does something that looks like a for each is a great example. If you're iterating over one element of the stream at a time and only operating on that element and not saving them anywhere, then that works just fine with a borrowing stream.
This could have been, but you didn't have it yet.
Right.
So yeah, which is probably one would assume fairly common use case. It's relatively unusual to actually have to take things out that then live through to another
and you
iteration.
Could make that a backwards compatible change in this particular case, because you could add borrowing stream as a super trait of detached stream if you could spell the bound right, which currently you can't because HRTB doesn't.
Well, we don't really know exactly what that looks like, but yeah, okay. Okay, well, that's an important wrinkle. I see. Could make this backwards compatible by doing, or sorry, what you're saying is you could make it backwards compatible-ish. I'm not actually entirely.
It also doesn't quite work out because of trait objects, right? And trait objects not supporting implicit downcasting and upcasting, right? But,
yeah, although we are working on it.
There's work being done in a lot of these areas, but today it is not possible to spell this in a nice way. And it's sort of, there's a lot of paths to success here that involve uncertain futures.
So in your opinion, would it make sense to, like, how, I'm putting this backwards. No, I'm not. It's actually.
I see what you're saying.
Actually correct. Yeah. No, sorry, I'm just trying to write down what you said before I ask you my question. If we have this, but we would need better where clauses or something. Plus, we have to deal with.
There's bits and bobs that you have to make actually work.
Right.
And we had this problem too, like when we tried to have the future trait be defined a little bit differently.
Right, but my next question is, like, should we block on resolving all those things, or is the value that we get from a detached stream, imperfect though it may be, worth the bet that we're going to work this out somehow? And or if we fail to do so, then you just have some functions, like you have a lot of older functions that are too strict and they have to be loosened at some point or another. And maybe it's not 100% backwards compatible, but it mostly works. Like that's the worst case, right? That this function just lives on the way it is until somebody changes it manually, and maybe it's a 2.0 or something. But do you have an opinion about that, whether it makes sense or not?
I have opinions, but that's the sort of thing where if someone were interested in sort of carrying it all the way through with a proper design for how it was going to work out over time, I would be happy to assist in that effort and would love to see that go through. I would want to see it all sketched out, what the plan was first, I think.
So you would say if we had a plan that allowed us to add borrowed stream later.
I would want a specific plan for how that future impl was going to work, because my experience has been that there's a lot of things that like almost work, but then something particular in the compiler to do with how the order of where clauses gets resolved with something and creates a cycle, and you can't actually write it today on Rust, and we need something universes are going to help fix everything.
Okay.
And I basically want to know specifically a list of blockers for what actually that transition is going to require.
I guess what I'm okay. I think the other half of my question was, what if there didn't turn out to be a plan that made it a non-breaking change to upgrade, right? I guess that's part of your statement is you would evaluate the plan on that.
Yeah, so I guess I would talk about what that means for the future, right? So does that mean today that you would write async gen fn, right, to create a stream, write a few yields in it, right, and that would implement detached stream today, and then in the future the type returned by that would also implement borrowing stream.
Well, you just went a little bit down the road of adding some syntactic sugar, which was not what I was assuming, but like I was only thinking about the trait. But now you're saying there's also this other bit of sugar that we've certainly talked about of having a generator function or something that yields out a stream. Because I could see waiting, saying, well, we'll do the trait first and we'll hold off on the sugar until we have nailed down everything. But okay. Well, but this is already useful. So you would feel like when you say a plan, that plan includes interop between detached and borrowing streams, obviously.
Yes.
It includes behavior of async gen fn with respect to those traits.
Yep.
Which makes sense.
And it also includes something that's a little bit, well, yeah, I don't know how into the weeds we get, but if you start including the generators with our arguments conversation, and it gets hairy, but so we can skip over that. I don't think I need to see that all totally planned out for this part of the things to resolve itself.
Would stream be the number one, challenges aside, which would you say is more important of, like, say, let's just start with stream versus async read and async write? And like I'm coming at this initially, I think, with that lens of like Fuchsia and libraries that Fuchsia wanted to use, let's say.
So my personal opinion, and I know there is disagreement about this, and I want to respect that, and it isn't coming from like an invalid place. My personal opinion is that async read and async write, as they're defined in Futures IO today, are ready to go in standard, and that should someone should write an RFC for that, and there should be very reasonable discussion that goes over the goes over the sort of contention points, right?
So specifically, this is like with the signature that's, I forget what it is, but it takes a slice of U8 basically.
Yes, and as well as the vectored version of the same.
Right.
And the reason I believe that is because those traits are exactly read and write as they are defined today in standard, modulo adding the standard stuff to make it async. So adding pin and adding poll.
And vectored, do we have vectored reads and?
We do have, fairly recently they were added vectored reads and writes to the read and write traits. And we match those signatures exactly.
Yeah, I think that's a good, I mean, I think that's a reasonable argument that like there's value in matching consistency within the standard library.
Yeah. The sort of counter argument is that there are specific classes of applications that tend to use async read and async write, or just asynchronous operations in general, that have different properties from the things that use read and write in general. In particular, they tend to be things that are more performance intensive in a particular way that's like very IO bound. And so things like being able to use uninitialized buffers are very important. And today, the uninitialized buffer story for the read and write traits, or really just the read trait, is very unclear and has flipped back and forth between a number of different directions over time, and it has not been encouraging.
Yeah.
So that's part of where Tokyos want to define their own versions of async read and write, is to give them extra types via which to communicate data about uninitialized buffers.
Right. And well, I think I'll get more into this at some other point, but I'm curious about the interrupt. I haven't thought hard enough about it. At least not in the last 10, not the last minute. But before we go into this down this whole road, what I would like to know is what is it like? What does it enable to have async read and async write? Like, what class of libraries? And what else do they need?
So the big thing about async read and async write, right, is that they're enabling things like TCP stream and other things that have byte level communications that need to get pushed in and out of libraries to interoperate. So that's really common to see in the HTTP world, right? Is that you have some particular like byte stream that needs to get funneled through a particular type of communication protocol, whether it's one of the base HTTP setups, whether it's H2 or Quick.
Right. So you'd like to be able to say, you have some data you want to send. It's like your payload. And you kind of want to set it up with some protocols that add headers and encode it in various ways over the stream.
Is another good example.
Yeah. And you think that we could kind of build that whole, like, I don't know what's the right word, ecosystem of, I guess ecosystem. I was going to say combinators or middleware or something. And the main interface for that would be async read and async write.
Yes.
Okay. So like Quick, for example, does it need anything else or just this?
Yes, but they all need a little bit of something else, but those tend to be like protocol specific things too. But the ability to support byte streams is a core component.
Okay, but I'm not sure what you meant by they all need a little extra something, but what I mean is, like, do they need other features that are tied to the executor, like of sockets or something?
Yes.
Okay. I guess this is what I'm asking very concretely. If I had a Quick library and the async read and async write were instead, would I likely still have a feature that's like, for Tokyo, I do this, and
sure.
for
So
async std, I do that?
Creating a new TCP stream is always going to be something like.
Yeah, but if you're given one to, I guess, if you're given one to start that you build on,
sure.
So I guess you can sort of export some of that stuff out and have at least a subset that is totally independent.
Yep, you definitely can.
Okay, that makes sense. Yeah, it kind of reminds me of basically, right. When we can basically write wrappers, and this will let us write a few more wrappers, but what we're still missing is always going to be this base creation options.
Yeah, and in particular, async read and async write tend to be the places where having some sort of non-free shim is going to be really expensive,
right?
Because we're funneling a lot of things through them.
Yeah, and this is what I meant by interop around, like
many times through a single request, right? Whereas something like accepting a single TCP connection, like you're only going to do that once, depending on,
right. And you might customize it with closures or something else. Okay. So are there any other traits, or are we done with, like, if does stream and async read and async write kind of cover the set of interesting traits to stabilize in your mind, at least in the short term? Or are there more? Jumping
I
back to
think
this.
short term, the answer to that is probably yes.
And I guess
There
there's async
are
closures and
not,
async destructors.
right. So the reason I say short term yes is because there are a lot of other things that have greatly expand the design space that we're talking about. So async closures, proper support for async closures would be really big, and I think people are going to realize now that async await is stable exactly what things you're missing by not having them today. And there are some things that are really painful. In particular, the fact that like the closure passed to for each isn't allowed to capture its its captures. It's not allowed to mutate its captures inside the async block. Um,
Sorry,
it,
can you, so this is like I have stream.forEach or something,
exactly.
and I want to write
Yeah. So
async
just
item.
stay outside. Right. So exactly. And you want to say, you have some let mute x declared outside that block, right? X equals 0, right? And then inside the for each, you have like x plus equals 1, print x.
I'm going to do that. Okay, so I have like counter plus equals 1 or something. Yeah.
Right. So today that doesn't work. And the reason why is that the async actually today, you have to put it after the item because we haven't stabilized async closures. And what that does is that it will move the counter variable. Well, actually that'll error, but if you add a couple moves to this, it's going to move it into the closure. And then each time the closure gets called, it's going to move the counter variable into the async block.
Something like this.
You also, yes.
Yeah.
I think you also need move on the closure, but I could be wrong about that.
It's a lot of moves. Okay.
Yeah. Right. Well, and it depends what you're doing. You don't need that move if your future isn't gonna, if you're gonna await it immediately, but if you want to capture the counter.
Yeah, but the point is you're mutating this copy of counter, not the original counter.
Correct.
Which isn't really what
And
you
if
want
you
to
want
do.
to mutate, and if you want to mutate the original counter, you need some way to express a property of that closure that you can't spell today, no matter how hard you try with HRTPs and things, because I've spent a long time trying.
Is it worth talking about that property?
Yeah, I mean, I think it's really important. I think it's something that I would love to see exist. So
What is that property that we can't spell?
it's that the the future that's returned from calling a closure has to be able to reference the captures of the closure that it was returned from.
Let me write that down and then understand what you're saying. Oh, future returned by calling this closure.
So it's the sort of gaps
for some
of,
closure C, it returns a future
that
references
we
things
can make this more
captured
generic.
by C.
We can make this more generic and just say allow closures to return types that reference the closure up far.
I see. Yeah. Okay, right. And this is actually orthogonal from async move to a certain extent. Like I've definitely encountered a desire to have this before.
Yeah, there are lots of other ways you want this. They're just less common.
Right. So have a closure. Yeah, a closure that can return references to its own environment. That's what you're saying.
And in particular, mutable references to its own environment. And so you can't call the closure again until you're done using that value.
So just to spell this out for what we're saying, we currently have a trait that's like mute. I can type. And the problem here, just like with stream trait, is that this is effectively detached from the ammu itself argument.
Exactly.
Okay. A little ASCII art. Okay. So we need like a borrowing FN mute, so to speak. Oh, this is good.
Yeah, and there's different ways to spell this too, because if you're generic on args, you might also want the trait to be generic rather than actually making the call function generic. But
what do you mean by that? Sorry.
Meaning that you can put the lifetime as a lifetime parameter of the trait rather than a lifetime parameter of the call function. But that's the same conversation around like stream being something you can define today if you get particularly clever.
Why would you want it there? You're saying I might want this?
You're right, but
then you could only call the closure once.
Sorry, no, because
in a generic
you'd say,
context.
the way that you'd spell that then is that you'd have an HRTB over the borrowing FN mute of ticket,
yeah,
or ticket.
So the only reason you might want that is to
Anyway, but yes, you're right.
Okay.
Again,
it would certainly be less ergonomic. I mean, one reason would be to express it sort of today, and you're saying you'll hit obstacles, and I agree.
Right.
But is there another reason? Like,
I feel like I've hit something at some point, but I can't spell it out.
All right, it's fine. That's really interesting. And the most frustrating part of these whole things is every time I come on this pattern, I think, boy, it'd be great if we could find some way to like hide this so that you don't have to deal with all this complexity. Yeah. But then I remember that indeed, like in generic code, it makes a big difference. Like it sort of sucks that these are different traits, but actually they're really different.
They are really
what they permit you to do. And it's kind of important.
And in the first one, also I want to point out that once again, our borrowing FN mute or type output of TICS has an extra where clause on it that we haven't written.
Gosh darn it. Yes, you are not wrong. And
Sorry,
it's probably also this, incidentally, just for extra fun.
Right, because you want the output type to be able to capture references to the argument.
I'm not sure maybe it doesn't need that actually. I was thinking that it would.
Well, I mean that is a very useful thing. Like in the example above of stream for each, that is what you want, right?
Right.
So yes. But
it already can capture things. It can't borrow them. Okay, anyway, that's fine. I don't want to go too deep into this. Suffice to say, we have...
The output type there actually would be expected to outlive A potentially, right? It just has to... It's only constrained to live as long as the call. And so if the call were longer than A... Anyway.
Well, the output type here is... It may include A, because it's going to be like... can draw on this type A, but I don't know. It
might, unless A were static, it wouldn't be able to. Anyway.
Yeah.
I agree with you. What you said the first time of that the where clause should actually include A outlives TICS.
It probably should. I bet. I don't know. I'd have to work it out. This is like the thing from a design perspective that I still feel pretty unsatisfied with, but around generic associated types. Okay, so that's async closures. We're kind of, I would like to start wrapping up, but so what about, I think the most interesting thing to ask you about would be a little bit about the futures crate itself and these, maybe some of these combinators and utilities. I mean, one thing I know you've expressed to me about the futures crate is sort of, it doesn't make sense to have a 1.0 release of the futures crate because that should be standard. Like, at least that there are a lot, I think there's probably, maybe that's not quite expressed right. There's at least some set of things like async read and async write that should move to standard rather than living long-term in futures.
Yeah. So there's Futures today is divided up internally into a few different libraries. Futures Core, Futures IO, Futures Sync all express sort of standard interfaces that some version of them, once 1.0'd, I think appear in enough places that it's valuable to have them in the language's standard library, so that we get all of the benefits of those being
So which was that? Futures IO, Futures compatible. You listed 3 crates. Futures Core, was it? Or Futures IO?
Futures Core, which is Stream, basically. Stream and the fused traits.
Okay. I know there's some, well, at least from conversations I've had with Yash, there's been some dispute over how important sync is, but I don't want to get into it at this moment.
There's lots of dispute over how important sync is, and so, yeah. But if everybody agreed that those were the abstractions we wanted, I believe that the most useful place to have them is in standard.
Yes, and then the remaining things in future are like utility combinators?
Yeah, so Futures utils and offers a bunch of tools that are basically things that you will probably want, or things that many people want when developing futures-based or asynchronous applications. So this includes all the things like the extension traits, so for each, try for each concurrent, as well as join, select, all of those sorts of goodies.
Yeah, and so so this seems sort of analogous to like the iterator trait has a lot of methods, many of which you don't want in any particular thing. And then there's like an itertools crate, and then every once in a while we move things around between them.
Yeah.
Is it kind of like that? Like, why wouldn't, for any one of these methods, it could also be in standard if we thought it sufficiently useful?
The TLDR is that there are a lot more choices in them than you would want there to be, which may be obvious from the fact that one of them is called try for each concurrent. And things like filter, whether filter should return a future of a bool or a bool, right, are things that have those sorts of design decisions have to get made all the time when you're looking at the futures combinators, and they're strangely contentious. And so there are sort of, I could see different opinions on those, and we've taken our own stances, and I think what we've managed to come up with is a relatively consistent set of functions, but there's certainly still conflict to be had over it. I will also say that a number of them have sort of canonical versions that you can't express today. So like I was saying before, the proper closures, signatures for things like for each or filter or many of the other traits are not actually possible to write today because you can't express the closure bound correctly. So there's a whole bunch of reasons why the functions that exist today aren't sort of the canonical ones that are like peak version of this function, or not unambiguously the correct way to write that function. And for that reason, I think that it's putting them in standard is going to be a significant challenge. It's going to be a significant use of team resources, and I don't think that it's the right choice at this time.
So that's a really interesting point. So what am I correct to take away from this that there's a dependency between async closures and these combinators in a lot of cases?
Yes.
And basically there's no good reason we can add them to standard later. And for the time being, they can live in a crate. And that's a sort of sort of backwards compatible change modulo the method resolution problems that often arise when we try to do that kind of thing.
Right. And in particular here, that's sort of a weird question because we also have our own version of the stream trait, right? And whether, what the impl directions look like that, like for that and an eventual like async gen fn's stream trait.
Sure, that's a good point. Although I'm imagining, that's a good point.
But I'm saying like if there were like a compat thing to go between them, like you would want that to be a different, that would resolve sort of the method resolution issues. But yeah, you're correct. And I think that that's a really important thing to point out too, is that you get a sort of backwards compatibility here. by keeping these all in a separate crate from those standard traits. And that's the core big idea behind Futures util, is that when we unlock these new capabilities, like async closures of this new shape, right, we can make a breaking change to the Futures util library that allows for this new expressivity and these new abilities without breaking any existing users and without breaking other libraries or intercompatibility between them. Where if we built them into the stream trait, for example, making a breaking change to one of those combinators would mean that we also were making a breaking change to the stream interface, which would be massively crippling to the ecosystem.
Mm-hmm. Yeah. I'm basically trying to picture in my head what the sort of story is that people want to be building things.
Yeah.
And I think the story of we're going to be migrating these things to Stud, and probably we're going to have some compat layers such that you can build things that rely on Futures 0.3 or whatever, although whatever version numbers we end up with.
Right.
And we'll kind of bridge them. They have a path to be used in Stud, right?
So today, you can go out into the world and you can write your applications using Futures 0.3, and I would encourage you to do so. I feel like that's something that I can recommend at this point. You can use both the current Tokyo stack and Hyper and the ones that are coming up. You can use async Stud. There are a whole bunch of other nice libraries that are going to be releasing versions that are compatible with Rust async await, and you can and should use them with the other tools I mentioned before. The situation will get better in the future, and new things will be released, like at some point, hopefully async gen fn. And when that happens, it might be that you want to pull in a new version of the Futures library or a new version of some other library, but that hopefully should not result in the same sort of ecosystem-wide fallout that came with the release of the future trait in standard.
Why? Okay. Assuming that, so if you directly depend on Futures 0.3,
right,
you are, and you wish to upgrade.
So when we say you depend on Futures 0.3, I'm primarily, the last handful of things I said was for people building applications and web servers and the end users of Rust's async ecosystem, right?
Yes.
So for library authors, the story is a little bit more nuanced, and you have to be a little bit more careful about which pieces of things you take public dependencies on.
That's what I was trying to understand. Okay, that makes a lot of sense to me for end users. For library authors, presumably you would probably try to keep only sort of private dependencies on future util, so to speak.
Right. So here, the places that you can and should take public dependencies, as much as you can, try and limit yourself to Stud future, because that's the one perma-stable interface. There are a handful of other really things that are deemed like really stable, like the stream trait inside future, and async read and async write inside, and those are inside Futures core and Futures IO. Those are things that we don't anticipate changing anytime soon. They're relatively like the obvious thing.
What version number do they have today?
Ongoing discussion about how to change them, modulo, how do other libraries work.
Are like Futures, is Futures IO 1.0 crate?
I would consider it
0.3?
Everything in Futures right now is released as, in terms of like, what does the crates IO thing say? They're all 0.3.
Okay, that's what I meant.
I consider everything in Futures IO, which is async read and async write, to be STD level. Like, at this point, I would be surprised to see something go into standard that wasn't exactly those trait definitions, and I would hope that 0.3 of futures.io could be changed to simply re-export standard and do nothing else.
I see. So if we, that's interesting. So if we adopted async read and async write just as is into standard, we would basically release a new 0.3 that re-exports, and we'd probably release a 1.0 that we'd probably do the Semver trick or something also and have a 1.0 that 0.3. I guess we don't need a 1.0 because no one ever can use that crate again.
Yeah, right. And the point of releasing a new version of it would be so that all of the people who were in libraries that were relying on futures.io now just instantly were intercompatible with the types from standard.
I mean, it seems like at the minimum what we could do is make some kind of commitment that these types should be efficiently interoperable.
Right.
I don't know if it means anything different than
right, and right, and that's something that and the core thing that's holding us up from doing that is what
right.
what
This
happens with
initialization.
memory, basically. Yeah.
Yeah, it's not. That's one of the real thorny parts of this is that efficient interop. If you don't know that your data is initialized and you pass it to this method, you sort of need some way to avoid doing that initialization, or you won't be efficient.
Yeah.
For some definition of efficient.
Yes.
In Fuchsia, you're using futures.io, async read and async write.
Yep.
And you haven't observed zero cost, or haven't observed zeroing to be a very expensive operation.
We do zero things. It is not usually. It is something that it has like constant factor consequences that are observable, but not something that like we're worried about for our own reasons. But that's not to speak for the greater ecosystem. Certainly things like Hyper, like it would be very expensive and they would take like a benchmarks hit, like if they just started not.
Yeah, no. I'm not trying to encourage you to make a sweeping statement about anything else. I just wanted to ask specifically if you had measured the cost in Fuchsia.
Yeah, it's not a lot.
Okay.
Like,
I do.
It gets lost in the noise, basically. Like.
Right, but I definitely can believe. I mean, I've pushed a little on the thread and got some benchmarks, and they were persuasive to say that there's, for certain applications, definitely a fairly observable cost.
Right. And that's mainly because in Fuchsia, generally, like most of our things aren't even using async read and async write because they work over our own serialization protocol, which has its own set of constraints. But
okay, that's an important variable. I mean, for sure, if you're at minimum, if you're doing proxying or something like that, which is what these benchmarks are basically measuring, it's pretty darn noticeable.
Right.
Okay. All right. Any parting thoughts?
Lots, but select is really interesting.
Yeah, I remember us talking a little bit about it.
One of the most useful parts of futures, and one of the ones that's sort of the most interesting.
I mean, what I remember was I have a vague memory of you telling me essentially that the thing you most obviously think you would want to do is to sort of take ownership of the futures you're selecting over, but that causes a problem when you're in a loop.
Yes.
And
there y'all should go, if you haven't gone and read the async book chapter on select and concurrency. I would very highly recommend it. It makes all of this pretty clear, I think, and I've gotten good feedback from people on that. So
pull that right up, just so everybody knows. Not this one. This one?
Select, yeah, under executing multiple features at a time.
Awesome.
And this talks you through both why select is great and some of why it's weird, and how you can use it that it's weird to do some really powerful things.
Awesome.
And along those lines is also the one of the most useful combinators inside of features that is also one of the ones that is kind of hidden is called features unordered. It's a thing people should be aware of.
Just in order, does that kind of take multiple features, let them execute in parallel and extract the first one or something?
It does.
It's kind of a race.
Exactly. It's, yeah.
I still want this to work, by the way. Never mind. I still want tuples to be awaitable. And then I was chatting about this with Yehuda and at some point randomly, and he was suggesting this, and I was like, yeah, I like that. But anyway.
Yeah, I mean, I can talk with you about why I don't like that for select, but I do like that for join. I mean, I don't know that I like tuples as the syntax for it, because I think that it's kind of hidden and makes it discoverability tricky. But
yeah, I think that's true.
I think calling a library function called features join is pretty obvious, and calling dot await on what seems to not be a feature at first glance is.
Yeah, I think it's something you would just teach early on, but that's not necessarily the best argument. Anyway, yeah. It's okay. We don't have to have this debate.
We have a lot of things that you have to teach early on.
Yeah.
More than other languages at this point in the async land.
All right. Let's call it here. I think this was good. I'm going to try to turn these. Well, I haven't quite figured out. This is early on. But I'll try to take these notes and make a more readable summary out of them, at least. Thank you.
Yeah, thank you.
And see you later.
Bye.